It's working.
Yeah.
It's not. Okay, good afternoon and thanks for coming. It's the same thing. Oh, you have the mind?
For online.
Okay. So although the title is basically Super El Niño and seasonal, but it will be less on Super El Niño and more on seasonal forecast. But a little bit of Super El Niño. So this is what typically we see. There are so many forecast systems in state that seasonal forecast systems. So this is T3S, one of the seasonal forecast systems where SMW is also part of, isn't it? So they do forecast, and this is for the month one lead forecast. That is conditions. There are 51 initial conditions they have. We have average over the 50 initial conditions and initial runs. So this is their forecast for August. There's a well, there's a line of increased rainfall here and decreased rainfall here. And what India, South India are very, very low, and Northwest India is very, very low. But Central India, some are very close to mean or even then Northeast India again below average. This is, I don't know, this is not a, it's also not a typical in pattern, isn't it? Not an inclined response typically, but this is there at least one forecast phase. There is a latest one from the July order. August, it has not yet come. So what this forecast was done like this, basically. So this is the world calendar of valid dates, including the valid dates, whatever it is. And so initial condition starts every month. There will be many initial conditions every month, but then finally they average, right? And zero leap means it is yearly, and 1 year it will be valid for the next month, and so on and so forth. So this can be called as a model calendar or forecast. That forecast goes in this direction. So this particular case, since I have taken August, which is here, and started in July, so this is 1 week. This is started here and this here. So therefore, you should be able to get another year at least for September, starting at the same initial condition. Or same August, we can get from another initial condition, June initial condition. So same August from June initial condition or September from July as well as June initial conditions. That is September from June, July as well as June initial conditions. So this is the August, again same August forecast starting 1 month before. And surprised this pattern has not changed for some reason. This entire pattern has not changed. But the if you look at these anomaly magnitudes, they have decreased for some reason. So these anomaly magnitudes, including even these anomaly magnitudes, have decreased, including these dry regions, anomaly magnitudes have decreased. So this pattern that wherever it is raining more is again surprisingly the region where in August it rains the most. This is the climatological August from the model itself. It lead to I just made to show that I read for the model itself because model varying in a different location pocket observation. So this model's climatology at lead to basically this will be the lead to here for August. So this is the region where it rains most of the locations. So basically it's saying the same location where it always rains in the model in the August. It will rain more than the other regions where it northern side of the so-called IISc be very dry. So I don't know why. This is for the September again, starting in July as well as June. But September is much drier. And in fact, while in August, as we came from June forecast to July forecast, August forecast anomalies have, but for September forecast, June versus July, anomalies have intensified. So dry anomalies have become far more now instead of September. And somewhat disconnected to the rest part of the West Pacific Ocean. So I don't know whether they will change whether in the next week or not. Not very sure. The problem is this our El Nino that we have discussed so many days. And this is the latest last month's anomaly. This is the region of average of El Nino. Those are possibly the news. Some of the news students may not know. And this is from the IISc forecast, IISc log, observation. And this is the monthly average, monthly variations of the 3.4 anomaly, FST anomaly here. So currently it is about, I think they said about 1.9 or something, latest to check, last week or something, very close to 2. So and then they say that 2 greater than 2 is basically super El Niño. So it is actually super El Niño is not yet here. In ideal, super El Niño is not yet here. What of that? Last whatever, this is from 84 or something, the data is there. There are 4 instances. This is where we came to a super El Niño. There are at least 3 instances of super El Niño, but none of them happened in June to September. I calculated that calculation from June to September. They never happened in June to September. If you the strongest El Niño we know, strongest El Niño comes in December. So, but it doesn't say that it will not cross 2 in September. It can be even stronger in coming September, coming winter, but it never happened. So, and most of the models are predicting increase further. Dynamical models are more than the statistical models. And this is also typical. I'm sorry, these dynamical models are dynamical models more than severe. This is also a typical pattern that even the last years I have seen, even for line, dynamical models amplitude is usually smaller than the dynamical amplitude is more bigger than the statistical model. So statistical model possibly missing something better. So there are many other patterns here, like warming in the Indian Ocean, like including Bay of Bengal and the Arabian Sea and the Pacific Ocean. There are cold days here and this one. We can keep on talking about different this one. But what I wanted to show here is the calculation of this itself, 3.47, because there are differences in the calculation of the 3.4, and this day there is something called R reflective oceanic index has come. So I'll just try to do that calculation. So what we do is that this is the mean SST evolution from last 50 or 70 years. This is here. There is a warming of about close to 1 degrees. This is only 3.4. Sorry, this is a global mean, 3.4. Global mean increase is about say 0.7 degrees or 0.9 degrees here. This is the spatial map of the train. So most of the increase you see in Indian Ocean, eastern side, West Pacific Ocean, North Pacific Ocean, Equatorial Atlantic Ocean, and everything. Not much here. Not much here, but northern side, southern side. So the point is, this region of the Pacific Ocean is anyway colder than this. So climatically, this region, eastern side, is colder than this. This is all the side is central. So basically, there is a negative gradient if you go from west to east. And this warming has made the gradient stronger. So that possibly would also have some impact on this, on the El Nino and monsoon connection. But what? Because of this warming, because there are some warmings here and there, and part of the warming would be just overtaking the 3.5 itself. So NOAA have come up with something else as a relative ocean index, which JS has already discussed here a long time ago. But I just made a calculation. So what you do is that ONI is basically your monofrequent anomaly based on 30-year running climate that is shifted after every 5 years. That's why one standard is there, isn't it? Now for relative Nino, you calculate this first, then remove the tropical mean SST anomaly from that value. Okay. But then what will happen is the standard deviation is different of this here. Then you re-standardize it that each and every month of calendar month and make sure the standard deviation of RONI becomes equal to the standard deviation of ONI itself. So just a simple ratio you can do a calculation. So if you calculate this RONI and ONI for the same time period, you see that it's obvious that in the recent time, RONI is less than the ONI because you have subtracted the anomalies which are warmer because things are getting warmer in the other regions. And in the earlier days, that your ONI is weaker or less and is more negative than the RONI. If you do a scatter plot, it's again these are the colors the years. So ONI is larger when it is a recent years, and RONI is larger when it is compared to ONI it's this year. Okay. Now you take so basically they are almost similar. There are magnitude-wise difference, and we make sure that the standard deviation of internal standard deviation of each and every month of RONI do not differ because that's by construction. So if you can take any of the data, so we have just taken this ONI if I remember, and do a PDF distribution of monthly ONI actually, monthly 3-month SST. And you find that this is positively skewed. That they basically more points, more months at a greater anomaly, positive anomaly than the negative anomaly. Okay, so there are more points. Basically, stronger El Niños are more frequent than the stronger La Niñas, which is kind of known. But possibly this has something to do with the Indian summer monsoon also. Long time ago, about 4 years ago, we have published with the one postdoc that Indian monsoon also has a skewness negative. Basically, it has droughts stronger than the floods, and more so during ENSO years than non-ENSO years.
So, and RONI is from the same pattern?
Yes. Yeah.
Same.
Sure. There's a some sheet I don't remember it now exactly, but because year to year there are differences, right? But there are basic PDF remains same. So then it has made sure that the standard deviation does not change month to month. Okay. Because that's my construction of probability. So given that there is some connection between 3.4 and rainfall over India, what we did is that just make a scatter plot of those two, 3.5 June to September versus IISc. This is a well-known scatter plots. Correlation will come say about -0.55 or something. Simply. But irrespective of this, we just wanted to look at this part. These are so-called Super El Niño of the June to September, right? And this is some kind of El Niño and it's something like this, right? These are the stuffs.
What are different colors?
Okay, that is basically the blue ones are the last winter there was a La Niña, and the orange one last winter was an El Niño, and the black one the last winter was a normal condition. Okay. So if you forget the color for the time being, even just average this part or this part or this part. I think apart from this very close or where the SST anomaly very close to 0.5, I do not see much of a difference in the mean intensity of the rainfall. Even if you go very strong El Niño, become very strong. So what I'm going to say is that if you just average with some band of SST, all the isomer, we just plotted here. So plotted here that SST anomaly between 2.5 to 7.5 and so on. Okay, and this is the mean isomer anomaly. Look at that. This is basically around the El Niño, so around 0.5. So it is not surprising very small. Look at this too. The SST anomaly has increased by 0.5, I mean on an average, There's not much of a change in the estimate. So these are all basically known. Let's say in 1997, the same thing happened. There's such a strong El Nino, nothing happened. It was not there. There are several other mechanisms. Do not know why possibly, but it just happens like that. All right. So on an average, it is true. Possibly more, we can keep this one to this previous winter's La Nina because all these blue dots are at the bottom, the thick orange dots. This will come, this can give us a more predictive values than this exactly. What I mean is that El Nino above a certain threshold, anymore doesn't matter much. That's the point here. That's the point. And this year, you know that it evolved from a December La Nina. This is ROA line from there also only. Point minus 0.92. Currently, it is May, June, July. Just now it carries our one May, June, July average. So we are just transforming from the La Nina to El Nino. And therefore, you are likely to be again. So if even the anomalies are somewhere here, we are likely to be somewhere dispersed because where all the blue dots are there. So this is there we will go for the scale of the forecast over Indian land. Now we have seen some ICMW plots. I have just only taken one model and just which was some plots quickly possibly. Okay. So this is the bar plot of ICMWF forecast over Indian land region. So this is GBCP against plot over GBCP. This is over land. Okay, ICMWF forecast. This is a leak 10-1 basically. So this is June to September average, but details don't worry. Actually, this is quite good, to be honest. But I have not seen even CFS to model out so many days. But I have not seen such a good prediction. This is the best model. But lead one, that's basically lead one. Basically, when it was in June, the model started in May. July model started in June, and so on. So our average for different initial conditions, we ensure that each and every month rainfall has a lead of 1. That's all. That's all. But that's fair. I think that's what it's called. Lead one.
So you're starting from 1st of June, so July or September, June will be with 1 month lead. July will be actually 2 months lead, right? But it's taking every 1 month previously and we are JCIS for that.
Second. So basically, when I take June here, I take May initial condition.
Okay, and for July,
I take June initial condition.
so it's not a single run that.
It's not a single run. Yes, sir. So all lead one average. That's all it is typically counted as. All lead one average. So basically based on the target rather than initial condition.
Yeah, that should be better than, let's say if it was single run.
Yes,
Better.
yes. Because you have to have at least lead 4, 0, 1, 2, 3, 4 at least. So another surprising thing is, I mean, although it is very good, but the problem is even there are years like 1997, look at it, huge negative. Like 1994 also it could not capture. There are like I think 2019 also failed. Yeah, 2019 also failed. Like then I plotted, I think the next one, the lead 5, there's a 5 months. Similarly, 5-month lead calculated. And again, similar, there are few years it has gone here and there. But one thing to interesting is the scale has degraded. I'll show that scale has degraded, but the scale of the recent year's forecast has not degraded much. There is something is there. You look at the recent years, all anomalies are correct apart from 2019. 2019 also. This one 2018, well, 18, I think 18 has gone wrong. 19 became closer. So on an average, the recent years prediction skill has not changed even from lead 1 to lead 5. So I don't know what is happening. There must be something good to the model or data assimilation. So the model they do not change, the data assimilation they keep on changing. Then there must be doing something.
So from lead 1 to lead 5, if I look at 2019, something right?
Yeah, exactly. So 2019, it has actually become better. But there are 2018 has gone wrong. With on an average, 2018 has 2018, yes, 2018 is here. Yeah, it has gone wrong. 2018. So So this is basically, this is 120. So the same model, then how much does it? So since it depends on initial condition, what does it do for this year? Same ECMWF. Just plot this. This is ISMR prediction for 2026 from the same model with different leads. Leads 0 and 1 you don't take because why? Because yes, this is August, When say August, you do not have lead 2. Sorry, lead 2 you have. September you don't have lead 1 because August data is not yet available. So first 2 can be discarded. Just look at this from this point. So lead 2 gave the least error, or sorry, anomaly, not error, for this year. And lead 5 is the least anomaly. I don't know which one would be right. But look at their climatologies for all the different leads. Different leads have different climatologies over in Indian region. And it's very clear that there's a trend here. As lead increases, climatology keeps on decreasing. Observation is somewhere in between here. So, in other words, that model becomes drier and drier. As this goes, forecast keeps on forecasting for a longer lead. Model becomes drier.
So it has a driver.
It has a dry bias, but more so for longer lead than not. The shorter leads like this. Although we cannot take the forecast, but we can take the mean because it's a very long term, those data are available. So this is our 0.777 point is very, very close to observation. Problem is coming here. So at a longer lead, it's becoming shorter, it's becoming drier, but still not as dry as many other ones. So then we just plotted the scale of the model for ISMR forecast at different things, 0, 1, 2, up to 5. Look at this. This is the RMS error, orange line. Initially very low, 0, actually, although we should not see this, then jumps up and flattens. And then correlation coefficient, initially high, jumps down and flattens. In other words, there is not much of a difference between the there is not much of a difference between the scale change with lead from 1 to 5.
I'm sorry, but I have a question from a previous
slide. No?
How is this climate loss calculated from a model?
This one. So this each and every season has a valid. Season is a target. So you based on initial condition and lead. Sorry, based on the lead and the target, you find the initial condition. You get the forecast, right? Every year you have forecast, and mean is the climate level. The target area. So, what my point is that the month where the forecast starts, usually errors are low. Then from the next month onwards, there is hardly any change. See, month 1 to month 5, the change is so little, won't even kind of ignoring kind of stuff. Okay. And this is very similar to what we found earlier. That we have also done using CFS, sorry, this income model, that's NCMW models, and also I have done ECMW model. That forecast with lead time, the degradation of the forecast is not like a linear, it's like an exponential. Initially, it becomes very fast. After that, flattens out. So it is, and so it's very surprising that same mechanism works or same kind of phenomena is there even in the seasonal mean forecast. Now, this is the last part of this one. This is, I think, you have shown right last time. This is a spatial map of the skill score. Tejas, spatial map of the skill score, okay, of the rainfall forecast for the June to September. Sorry, DTA, lead 1. This is from the same model. Okay, so basically, again, lead 1, June to September, I think, sorry, DJF, lead 1, you have observation, each and every bit you calculate the skill. Okay, and we have already discussed last this one that very high skill here. Look at this, but the ocean, right, close to very high skill. Now, if you go here, this is June to September. See, it has gone up here, right? It has gone here. So more because it was less more. That's all. Equator has slightly decreased. So if you just average this in longitude, that you calculate the same skill called each and every degree, but then you average over the longitude. What will happen? You will find the zonally average skill, not the skill of the zonally average rainfall, but zonally average skill, isn't it? So that we still keep the skill of every degree intact the way it is. You have a look at it. This is TJF and JJF, lead one. So at near the equator, both TJF and JJF have a similar skill, but in summer, northern summer, skill increases substantially the northern side. Okay, so I'm coming to next. Okay, and then the lead three very similar. It doesn't matter which lead you have. Okay, so there must be something. There must be something in the model that the summer hemisphere. And look at this event. DJ, this region it has higher skill than the JJ's what this region, right? JJ's this region is higher than the region. There must be something in the summer hemisphere. So to do that, just made a scatter plot of the precipitation in x-axis. Everything is forecasted. Okay, nothing observation. Rainfall forecasted versus correlation scale. Nothing. That is the speed of each and every point versus the mean rainfall over that region. Nothing. Now this is P1 versus correlation coefficient if you do. Better than this, but it's so much of scatter. It looks like an increase in P1 will increase your kind of correlation coefficient to some extent. There could be something. Okay, so there could be something related to the precipitable water. So next what I did is that you go to each and every grid, find out the mean precipitable water over the grid and mean rainfall over the grid, right? And based on a particular range of UR and the rainfall, being average, basically that histogram, two-dimensional histogram type of basically nothing. Not histogram, like mean basically, not the histograms, not the number. So this is here. So color is the correlation coefficient. And this is PUR, and this is precipitation. This is June to September, lead one. It doesn't matter what lead I have checked. All leads are similar. So reddish means the higher, better skill. Okay, look at the better skill where the PUR is large, not rainfall is large, right? So this is the place. Even when rainfall is large, PUR has to be large for a higher skill. Fine. Now go to December, January, February. It's even more so. Look at this. So strong. All high skill regions are here. High PUR and high rainfall. I would even think basically high PUR only. PUR only. Otherwise, you could have got here something. Just because high PUR keeps rise to high rainfall, that's the reason those regions are red. That's all. Isn't it? Now, this stars and this one, no? Stars and this are the, now each and every box here comes from various parts of the world, isn't it? It could be over land, it could be over ocean, isn't it? Because I have not marked out everything. So then I marked all these regions where land is more than 70%. All these grids have land more than 70% land, and here more than 50% land. So basically 70% includes 50%, but you don't have to do that anyway. Correct, no? So if you do that, now you notice that here, in June to September at least, there are pockets of high skill region where you really don't need high rainfall or high PUR. To some extent you get PUR, but the pockets of high rainfall region here. All right. So this must be related. These land regions possibly are orographically limited or other regions where you basically there is a climatological condition of lifting, and you keep some amount of water vapor. It is going to give, and if your last year calculations are correct, it is going to give you a correct prediction. This is primarily the prediction, isn't it? You don't need the other conditions. But about over the ocean, these are the increase over the ocean. Absolutely, you have to have correct PUR. Enough PUR, not correct PUR, enough PUR. That's all. Now, maybe just 2 more minutes I'll take. Okay, then just to understand that we can do this kind of a calculation, that is your we do from the simple moisture budget, so P minus E can be proportional to this is Indian meteorology. Yeah, proportional to this one. If you ignore the horizontal advection terms and all those stuff. We just plot this P minus E versus this is P minus E, actual P minus E from the data and from that this calculation. There are differences, but actual variability is very, very close to each other. You may look at it. This is, but there is a bias. I don't know bias because possibly because of the evaporation calculation to see or to be horizontal advection not taken care. Shankar is doing a lot of work on these things. But this is one avenue to go forward possibly that even we can understand now high keyword regions, why so much necessary over the ocean to have good forecast skill. I think that's one point you must understand. I think similar over West Pacific Ocean, and these things not necessary. And this is East Pacific. This is 3.4 digit. I was surprised. Actually, mean W, this is omega, is descending over 3.4. We started 3 o'clock today. I think that's all right. Okay. So mean keyword is mean omega is positive over this region. And this particular thing is started here. I mean, keeps it correctly. Thank you. Okay. Yeah, any question? Others?
One question, when you said about the threshold, after one threshold of Nino 3.4 index, it doesn't matter to ISLR. Like it doesn't have major impact on ISLR. Is it only for Indian region or it can be said for global, like other regions?
Yeah, this I don't know. Most probably from everywhere, I think so. Apart from the local regions. See, I think what happened, because if you're very strong SST over that region, it must have got built up after a long time. So by that time, it has changed the SST anomalies throughout. So until IISc change the gradient, mean change will have some impact, but gradient is more important. So gradient itself is not so much like a as not ENSO. So what is the point? Okay, thank you. Okay.
Comparing only reasonably forecast right here.
Yeah.
Yeah. So the role of water vapor may be because when whatever is high, the error in entrainment may change, right?
That's also there. This one, right?
Yeah. So last week I already discussed this issue that the month of July had 1% above normal. Yeah. So you can see that we managed to get above 1%, but I wanted to notice the second India. It's huge. Okay. So 33 were above normal. Other two regions below, contributing about 1%. In August so far, again, Central India is 2% of normal, all others are negative. So this year, this region has been essentially preferred. Yeah, and look at this. Two events controlled July rainfall with a great from rain there. This is today. Now I just looked at the forecast made for last week. The for this. The forecast for last week, you can see that this was not bad for Northeast. Northwest also not bad. Huge error for Central India. So the IMD forecast of the high rainfall in last week of July was not captured, and South was okay. And country as a whole, country as a whole also I would say they don't do too well. They're plus 1%, it's minus 13% in that week. Okay. Now, it's also important to know what happened to the distribution. If you look at the last 5 years, from June 1st to the almost end of July, all the years, the number of districts above normal were 66, 64, 64, 64, 64, very uniform. This year is absolutely equal amount of good and bad rainfall here. So the pattern of last 5 years has not been repeated. And especially you can see that in July, this is the only region which got the heavy rainfall, both above and below are not good. And if you think in terms of IISc, the ultimate IISc was stuck here pretty much, okay? That's one you're looking at it. And you look at both June and July, of course, the June rainfall was not good in the middle of the Indian region. So we see all these things which were not in July, but still these two coastal regions had above normal because of July. Okay. Now you look at this result from this observation from India. You see that there was a low here which propagated, rainfall came all the way, went to Gujarat and so on, right? But you look at the weekly mean, you see a nice IISc. So this clearly shows the concept of IISc is valid only for weekly and higher regions. You can't look at daily. You can look at our ocean, you will see it. Our ocean is always a beautiful piece for the IISc. Or land, you cannot see it. You have to average or a week or 15 days or a month to see this pattern. Okay. Now, we had again a huge rainfall on August 1st in Gujarat. The number of stations above 100 millimeters is this large. I have not seen this kind of coverage of heavy rainfall this year in Gujarat. It happened twice. Okay. Now, all of us are hoping that IOD will come. There is some hint. There is upwelling in this region. Okay, it has not reached here. Only when it reaches here, we'll see some impact. But this is only August 1st. Maybe it will develop further. Now, sorry. The forecast for August is very, very poor. After the good rain in the last 2 days and few days, it shows continuous decline up to August 15th. Okay. So that is a bad sign. I think it's going to continue. And all the, not just Metro or even IMD and as well as European General, all of them show that monsoon is going to weaken. Now, one of the reasons we can see clearly is our discussion on Southern Malabar. Dry air is coming from Pakistan into India. And you'll see the interesting pattern. Here is a low which brings rain on this side. On this side, you're getting dry air. So you're getting an east-west dipole. High rainfall here, low rainfall here. Okay. And this clearly the role of a question of dry air from Pakistan going all the way across. Now you see IMD also showing the next 10 days well below normal. Okay. Now you look at the 4-week forecast, which is from Mithuna. You can see that this is the week we are in. Rain is occurring here. Slowly it's weakening. Okay. Even Bay Bengal is below normal. Look at 421st, everything is below normal. And here it really has. So the news is that the second, third, and the fourth week is going below normal. And this is confirmed by almost all the models. So that is the bad news. Look at IMD, little different. They are showing close to normal, above normal, above normal. And here comes the big thing. So everyone agrees that the last week is going to be bad and that will continue until September. That is the news. Now, this is the mid-monsoon forecast from IMD. At the end of July, they made their forecast for the next 2 months. Okay, so they're saying next 2 months will be 6% below normal. Okay, if that is correct, it's already below normal. The chances are very high that this year's monsoon will be at least 100 millimeters below 850, more like 750 or even below. Okay, so the forecast made in May will not be right. It won't be 6%. Now look at yeah, relative Nino has already crossed 2 degrees on August 2nd. IOD has crossed the 1 centimeter here. So if it proceeds rapidly, maybe there's a chance of recovery. Otherwise, it's not there. Now, what is the forecast for 3-month forecast? Well, October is not relevant to us. But what I wanted to notice is the large droughts are here, Indonesia, okay, and parts of South America here, Central America region. In India, it is below normal, but not as bad as the southern IISc. Okay? So I think there is some hope that it is not as bad as what others have pointed out. Now let's look at the SST pattern as of August 1st. The key feature of this year is, of course, a large anomaly here, large anomaly here, 5 degrees, and somewhat little bit of negative anomaly in the West Pacific, okay? And hint of a negative IOD developing here. Sorry, positive IOD developing. Let's compare this with 97. 97 had a much more negative anomaly in the West Pacific, which is not there this year, okay? So compare this with this. There is some hint, but there's no coherence in this. This is more coherent both in 97 and in 2015. Okay, in both of them, this region was negative, but this was positive. This year has not happened. Okay? Now I want to end with some interesting headlines from Deccan Herald. 1st August, farmers are installing coastal weather stations. Okay, and they're claiming better yields. Okay, now I'll give you my question. We all know that one data will not be better forecast. But this farmer is claiming he got better yield. Can tell me why? Anybody can guess. He got a better yield because of that. But I don't think he got a better forecast. So how did he get a better yield? There's a trick question. There's something that you must ask what you are measuring. Okay? It is called a coastal weather station. It's better misleading. What really gave him the advantage was soil moisture. That is the most important variable that is required for agriculture. If you know what the soil moisture is, you will be able to predict how things go and then also control how much water you want to give. So this was already done in Anandpur by when Sulochana and Shankar worked together. They put soil moisture sensors based on CDT's work, improved immediately. Because once you know soil moisture, you don't put too much water and also you don't forget about water. Okay? So his claim that yield is better is not because of rainfall prediction, but soil moisture prediction. Okay. Now there's an interesting paper came out a few months ago. I want to look at it. I don't think A is going to do great. A is not doing well in extreme events, which is not surprising because extreme events are few. You cannot bring them on. So this is a heat wave and cold wave. Look at the physics-based models and difference is huge. RMSE, here is 2 degrees, here is 3 degrees, 5 degrees. Okay. So clearly shows that all is because there's more training data. Extremes is going very tough to do. unless there is some other way to do it. Okay. Now I'll end with the interesting quote about air. So what is it? You need a whole thing. We are back to astrology. You have to go by faith. Okay. Because you don't know why it's forecasting correction. Yes. So that's the problem with AI today. Even if you get a good forecast in any 1 year, you cannot give a reason. So you have to go by faith. You cannot go by any logic. Okay. So that's my concern about AI forecasting. Okay. Any questions?
Any details,
Huh?
any comment on the flat flux that we are having in Kerala?
Huh?
Kerala with flat flux.
Yeah.
Starting southern.
Okay.